This is part 2 of section 9.2. We are using the quadratic formula to solve equations. And let's solve p squared plus p over 3 is equal to 1 over 6. Well, we need a 0, so I'm going to subtract 1 over 6 from both sides. So I have p squared plus, I'm going to move this over in front to make a 1/3 p, minus 1 over 6 is equal to 0. Now you can work it this way. You can say a is 1, b is 1/3, c is negative 1 over 6, plug it into the formula and get the answer. It really will work. But this is a fraction, and you want to plug in fractions into fractions? I mean, we know how to deal with that. They'll just be complex fractions, but why do that if we don't have to? And we don't have to. We can kill the fractions here, and it's the same equation. So we can kill the fractions and then use our new coefficients in the quadratic formula. So I'm going to multiply everything by our least common denominator, which would be 6. And that will give me 6p squared plus 1/3 of 6 is 2p minus 1/6 of 6 is 1. And that's equal to 0. Okay, so now we use this. And maybe I should put it more like that. It transforms into that. So our a is going to be 6. Our b is 2, and our c is negative 1. Okay, so our formula x equals, our variable is p, so p equals negative b, so the opposite of 2, so negative 2, plus or minus the square root of b squared, 2 squared, minus 4 times a, which is 6, times c, which is negative 1. And this is all over 2 times a, and a is 6. Okay, now start simplifying, and you have negative 2 plus or minus the square root of 4 minus 4, that's going to be 24, it's going to be negative 24, so this becomes plus 24. And this is over a 12. Okay, so I have negative 2 plus or minus the square root of 28 over 12. Okay, so we have a positive number inside, and 28 is not a perfect square, so we should get 2 irrational solutions. Now we need to simplify the square root of 28. And I'm glancing through our sheet to see if I see 28 anywhere. And I don't think we have it yet. So 28, that is divisible by 2 to give 14, which is divisible by 2 to give us 7. So its square root will be 2 square roots of 7. Okay, and the same thing happens here as happened on the problem before. We need to factor out the 2 here because the 2 will reduce with the 12. So when I factor that out, I have negative 1, either plus or minus the square root of 7. Think about distributing this back. You would get negative 2 here. You're going to get whatever sign is right here. And then 2 times this does give you this. And this is over 12. And now we can reduce the 2 and the 12, and you get a 6 down here. So your 2 answers are negative 1 plus or minus the square root of 7 all over 6. When you write your answer in set notation, you get this. Okay. So let's solve x squared minus 5x plus 20 equals 0. We've got our 0 already, which is nice. So our a is going to be 1, our b is negative 5, and our c is 20. Now plug into the formula. x equals negative b, so that's negative 5, so I write down a positive 5, plus or minus the square root of b squared, in parentheses, negative 5 squared, minus 4, because the 4 is always in the problem, times a times c. And this is all over 2 times a, which is 1. Okay, so I have 5 plus or minus the square root of 25 minus 4 times 1 times 20 is 80. And this is over a 2. Okay, 25 minus 80. This is plus or minus the square root of negative 55 over 2. Now our discriminant is a negative number, so that tells me I should have 2 complex solutions. We're going to have an I in there. We need to simplify the square root of negative 55, and since it's negative, we can definitely pull out an I. Okay, now, and then it would be the square root of 55 over 2. Now, we would try to simplify the square root of 55, but when we do its prime factorization, it's 5 times 11. There are no pairs in there, so there's nothing really we can do. So these are our answers. We have a plus version and a minus version. Now, because this is imaginary, because we have complex solutions, we do need to split this into 2 fractions. So our 2 answers are 5 halves minus I square root 55 over 2 and 5 halves plus I square root 55 over 2. Okay, so let's try this problem. The first thing we're going to have to do is to rearrange everything and get it into quadratic form. So we need to distribute the p, and we would get, so I can have room, I'm going over here. If I distribute, that's going to be 2p squared plus 3p is equal to negative 2. Now we need our 0, so I distribute it here. And now I'm going to move this negative 2 over to here so that I have 2p squared plus 3p plus 2 is equal to 0. So my A is going to be a 2, my B is going to be 3, and my C is also a 2. Plug into the formula. P is our variable, and this equals negative b, so negative 3, plus or minus the square root of b squared, so 3 squared, minus 4 times a, and a is 2, times c, which is also 2. And this is all over 2 times a, which is 2. Okay. So I have negative 3 plus or minus the square root of 9 minus 16. And this is over a 4. 9 minus 16 is negative 7. And so since it's a negative number, we know we're going to have 2 complex solutions. I need to pull an I out of this. 7 is a prime number, so the square root of 7 itself is not going to simplify. So we have p is equal to negative 3 plus or minus I square root 7 over 4. And now because this doesn't simplify any further, but because we have a complex solution, we do need to split it up into 2 fractions, just like we did up here. So your 2 answers are negative 3/4 minus I square root 7 over 4, and then negative 3 over 4 plus I square root 7 over 4. Okay, one last problem. I want to do 4x squared is equal to negative 9 minus 12x. Now you may remember that I said it's always easier if your a is a positive number. This is a positive 4 here, so I need a 0. I'm going to move both of these. over to here so that I can keep that positive number. Okay, so this is equal to 4x squared plus 12x plus 9, because I'm moving both of those over to the other side, equals 0. So in this case, A is 4, B is 12, C is 9. Okay, so plug into your formula. X is equal to negative B, so negative 12, plus or minus the square root of B squared, minus 4 times this 4 is part of our equation. It's part of the quadratic formula. It's right here. Times A, which is also 4, times C, which is 9. Okay, and this is all over 2 times A, which is 4. Okay, so simplify inside here, and you get negative 12 plus or minus the square root of 144 minus 4 times 9 is 144 over 8. We are finally going to be dealing with the first case of our discriminant. If the discriminant is equal to 0, then we get one rational solution. So we're only going to get one answer. Technically, we get it twice, and I'll explain that, but really, effectively, you're only going to have one. Okay, so this is a 0. Now, what do we have here? We have negative 12 plus or minus the square root of 0 over 8. But the square root of 0 is 0, so what we have is negative 12 plus or minus 0 over 8. Now, technically, we split this up into negative 12 minus 0 over 8 and negative 12 plus 0 over 8. But that doesn't even really matter because the zeros, you're going to have the same value on both of them. That's what I mean. Technically, you get this answer twice. But effectively, x is equal to negative 12 over 8, which reduces, if you divide both of them by a 4, that is equal to negative 3 halves. And that is your answer.